So previous class we discussed about the self-induction, right? So in self-induction itself, what did we do? We found out the self-induction of a solenoid. Remember what is the value that came out? Mu naught into n square A into L. U naught n square A into L. Right. Now what we'll do is we discuss about mutual induction also, no? So in mutual induction, what were the concepts that we have seen? So mutual induction, we understood this thing. What is it? The flux through the second coil is directly proportional to the current through the first coil. So N2 phi 2 is equal to M21 I. Flux through the second coil is proportional to the current through the first coil. So it should be I1 here. Right. M21 is going to be equal to N2 phi 2 the whole divided by I1. Am I right? So this is what you're going to get. And once you know that N2 phi 2 is equal to M21 times I1, differentiating on both the sides, what are you going to get? EMF induced in the second coil is going to be equal to minus M21 into dI1 divided by dt. So M21 is equal to, what can you say? It is E2 divided by dI1 divided by, right? Now the question is, we need to derive. So the next point is about mutual inductance of two long solenoids. So in the previous class, we derived the expression for the self-inductance due to a long solenoid. Now we are going to define the mutual inductance due to two long solenoids which are placed coaxial to each other. So what is going to happen here is you have two solenoids here. One solenoid is in this way and the other solenoid is placed coaxial to it, right? And both the solenoids are considered to be of equal length L. So what is happening? You have taken one solenoid, you have placed coaxial of that with respect to another solenoid, and both the lengths are taken to be L. And the radius of curvature of one solenoid is taken as R1, and the radius of curvature of the other solenoid is taken as R2. Now observe, there are two kinds of mutual inductances that we can derive. One is going to be M21, and the second is going to be M12, right? So we'll be deriving these two and trying to observe whether they both are coming out to be the same or different. Shall we try that out? So for me to define M21, what is that I need? I need N2 phi 2 divided by I1. So this clearly indicates, listen to this carefully, depending on what is the value of I1, you will be able to understand which is acting as the primary and which is acting as the secondary. So whichever coil is carrying the current I1, that is considered to be the primary. In this case, the secondary coil is going to be second one and the primary is going to be the first one, right? So when I say N2 phi 2, right, N2 is the number of turns in the second coil. Phi 2 is going to be BA cos theta. But listen to this carefully. Though I say that it is going to be the flux through the second coil, but the important point to be noted here is the flux in the second coil is generated due to the magnetic field from the first coil. Are you able to understand this? Why? Because we know that B is equal to mu naught into N into I. Right. So we know that B is equal to mu naught into N into I. So for us to generate the magnetic field, what is needed? You need current. But who's producing the current in this case? It is I1. So magnetic field the magnetic flux associated with the second coil directly has a relation to the magnetic field produced by the first coil. So B1, then what should I take the value of A as? Should I take it as A1 or A2 is what the question is. So listen to this. So when you consider two coils, right, you need to observe which one is having a greater radius. So if you observe here, what is happening? R1 has smaller radius compared to R2. Right? Means the black color coil has a bigger radius compared to the pink color coil. And another point to be remembered here is the magnetic field produced due to a solenoid is going to be present only within the solenoid. So the magnetic field due to a long solenoid is not present outside it, is present only inside it. We know this fact. So having said this, right? So when I say B is equal to mu naught into Ni, so due to the pink color coil, the magnetic field is going to exist only within it. Right? Then the flux that is associated with the second coil is nothing but the flux that is associated with the first coil itself. Why is it so? Listen. R2 is this much, R1 is this much. So inside this R1, there is magnetic field. And due to that magnetic field only, there is a flux that is associated with the second coil. So what is the amount of magnetic field that is there within the small coil? It is B1. And what is the value of the area of the first coil? That is going to be A1, where A1 is going to be smaller compared to A2. So the total flux that is associated in this bigger region is only present within the pink coil. So that is why this is a very tricky case. Though you write it as N2 phi 2, you should not write it as B2 A2 cos theta. Rather, you will write it as B1 A1 cos theta. So what I'm trying to tell you here is, for the flux through any coil that you want to understand, find out, it will always be due to the magnetic field produced by the primary coil. In this case, the primary coil is 1. And you should always consider the area of the smaller loop. So what is going to be the area of the smaller loop here? It is A1. So it is going to be N2 into B1 into A1 into cos theta, the whole divided by I1. And cos theta is going to be the same, cos 0 degrees. Because in this case, if you observe, the magnetic field is inside and the areal vector is also in the same direction. So for a circular loop, if the magnetic field is into the plane, right, the areal vector is also going to be in the same direction. So that is why I took it as cos 0. So here observe, it is going to be N2 into B1 A1 divided by I1. So N2, I'm leaving it as N2 itself. What is the value of B1? Mu naught into N1 into I1. What is the value of A1? So A1 as of now, I'm leaving it as A1 only. I'll substitute it as pi r square at the end. The whole divided by I1. So what is getting cancelled? I1 and I1 are lost. So what can I write capital N2 as? Capital N2 can be written as small n2 into L. Right. So this will be equal to mu naught into N1 into N2 into L into A1. This is going to be the mutual inductance of second with respect to 1. Am I clear with this? There is a mutual inductance of 2 with respect to 1. Those are online. Could you understand?
Yes, sir.
Yes, sir.
So here it is mu naught into N1 into N2 into L into A1. Or this can also be written as mu naught into N1 into N2 into L into pi R1 square. Okay. So write it down. They've written it in terms of capital N. N1, small n1 is capital N1 by L1. Enga. Nanda first is on L1 and L2 are same now. I told you in the beginning that you're taking both the conductors to be of the same length. L. One capital N2, one small n2. First is capital N2. Renda is small n1. N1 is capital N1 divided by L. Either. Mhm. L square மேல ஒரு L இருக்குல்ல அதை cancel பண்ணிட்டு வந்து it will be the same however you do. Are you done? Are you done? Okay. Now, the next thing that we need to derive is, shall I erase this? Because I need the diagram. Okay. So the next point that we are going to derive is we need to understand what is M12. What is going to be M12? M12 is equal to N151 divided by I2. Right. So N1 is N1 itself. So N1 is N1 itself. But what is the flux that is associated with the first coil? Now, if you observe, current is flowing through the second coil. So when current is flowing through the second coil, due to the second coil, the magnetic field is going to be completely within the second coil. But what is happening here is, if this is the amount of magnetic field that is present within the second coil, within this region only there is a small coil that is present. So whatever magnetic field is generated by the second coil is completely getting associated with the magnetic field of the, with the area of the first coil. So in this case, what will happen is N1 into phi1, how will I write it as? BA cos theta. This is where we need to be careful. So magnetic field is produced due to the second coil. That's the thing that is supposed to happen because that is the one which is carrying the current. But what about the area? Though the magnetic field is produced due to the second coil, the magnetic field that is associated with the first coil is going to define the flux through it. So what is the area of the first coil? It is A1. So what I'm trying to tell you here is whether you're going to talk about the flux through the bigger coil or flux through the smaller coil, you'll always consider the area of the smaller coil. Okay. The reason being, are you able to visualize what is happening inside? See, this is bigger coil and this is smaller coil. So due to the, if I say bigger coil is carrying current I2, due to the bigger coil, there is going to be magnetic field present here. Am I right? But what is the amount of flux through this surface? I need the flux through the first surface, N151. So what is the amount of flux through this? The amount of magnetic field that is passing through this multiplied with its area. That is why it is B2 into A1 into cos theta. Okay. So having said that, so B2 into A1 into cos theta divided by I2. So this will be equal to N1 into what is the value of B2? It is mu naught into N into I2 or N2 into I2. Mu naught into N2 into I2 into A1 into again cos 0, the whole divided by I2. So I2 and I2 get cancelled. So you'll get the answer as mu naught N1 N2 into A1. See, there are two ways to write this. You can write capital N1 in terms of small n1. So you can write it as mu naught into N1 into L into N2 into A1, or this can be written as mu naught into N1 N2 into L into A1. If you observe, right, this value will exactly match with whatever value we have derived previously. Check what is M21 that you have. Are they both the same? They will be. Because they'll be the same only if you take both the solenoids to be of the same length. If you take them to be of different length, then things would have changed. And one more reason why we have considered the solenoids to be in this phase, because the mutual induction will be maximum when the coils are placed coaxially. Because all the flux, that is all the magnetic field produced by either of the coil, will get completely linked with the other coil. That is reason. Okay, mu naught N1 N2 into L into A1 is going to be the value of M12. So M12 will be equal to M21 in this case, provided L is seen. Are you able to understand this? So make a note of. Shall I proceed? Huh? Come again for the given value of length. Okay. They'll be different. Because the value of magnetic field is flux is decided by whom? If you look at that expression, right, M12, that is dependent on which two parameters? Flux and first N151 divided by I2. So it depends on total flux divided by the current. Correct? So here what is happening is the flux that is associated itself is decided by whom? It is decided by the area, not by the length. Okay, it is decided by the area, and you have the number of turns which is coming out in this way. But fortunately, what is happening is, though you have the number of turns to be different here, N2 and N1 different here, but the combination, the product of those two is coming out to be the same. That is what is happening mathematically. And the second advantage here is, see, things would have changed had they both been of the same radius. Okay, here what is happening is they both are of different radius. So what is happening is, did you understand why I took A1 here in both the scenarios? Are you clear with that factor? Why? So in the first case, the magnetic field was produced due to the first coil. So where is the magnetic field due to the solenoid produced by the first coil? Magnetic field due to a solenoid will always be present only inside. So since the magnetic field for the pink coil is present only inside, the magnetic flux associated with the bigger coil is also going to be due to whom? Only due to the smaller one. So here the game changing thing is this one. That is why, though the number of windings in both are different also, as long as the length of the conductors is taken to be the same, the value is coming out to be the same, because the number of turns per unit length will play an important role here. That is why if you see, N2 is the one which is changing everything. Okay. So when you solve this is what we get mathematically. That's why the values are same. Orwell length where the things would have changed. If the lengths were different, right, then here you would have had L1, there you would have had L2, or the vice versa. Okay. So what is the important factor here? What is the important takeaway? It is not the number of turns, it is the length. Length should be the same. That is okay. So I told you, no, when you take the coils to be coaxial, right? I told you when you take the coils to be coaxial, then the magnetic mutual induction is going to be maximum. The reason is very simple. If you observe this case, right, they both are taken to be, if you observe this scenario, they both are taken to be coaxial. So what will happen is magnetic field produced by the first coil will get completely linked to the second, and magnetic field produced with the second will get completely linked to the first. That is why in this condition of coaxial, you are able to understand what is coaxial. So you have a solenoid like this. For that, you have the axis in this way. The axis of the pink solenoid and the black solenoid are actually matching. That is why we call them as coaxial. Okay. So when you do that, what will happen? Can you tell me? Flux produced due to the first will get completely linked with the second, and the vice versa. Whereas if you place them to be perpendicular to each other, what will happen? The flux produced due to this need not get linked with this. So this will be the scenario where the mutual induction is going to be the least. Are you able to understand? So this is another important factor, because based on the concept of mutual induction, we'll be discussing about a device called as a transformer. So in transformer, you need to understand how the windings of the primary and the secondary coil is. So just to put a question like this, if you want to design a transformer which is efficient, then what kind of a mutual, or what kind of a winding will you choose? Will you choose coaxial or perpendicular? You'll choose coaxial because mutual induction is maximum. Why is it maximum? Because the flux produced due to the first is completely linked with second, and the flux produced due to the second is completely linked with the first. You're able to understand? So this is what happens. Okay. You can just draw these diagrams and make a note. $52. Another question. $27 answer actually. 63 கொடுத்திருக்கான். 9 into 3 வரும். mu naught into n into I. So mu naught into n into I. Mu naught is constant. Number of turns per unit length is constant. அப்ப IM வந்து என்ன பண்ண முடியும்னா, can we try to write it in terms of drift velocity ன்னு பார்த்தா எழுத முடியாது அப்படி. It is basically a solenoid along the rectangle. increase by a factor of factor 27 தான் இருக்கும். 27 தான் வரும். அதான் வரும். 63 அது ஃபேக்டர் கிடையாது. இட்ஸ் நாட் 63. Are you done with this? Shall I proceed? So we'll do few problems that are based on self-induction and mutual induction. So for self-induction, the formula that we can think of is phi is equal to L into I. So we know that the flux through the coil is directly proportional to the current that is produced within itself. So phi is equal to L into I. And what is the self-induced EMF? E is equal to minus L into dA by dt. Right. So for mutual induction, again you can write phi is equal to M into I. Basically, you write phi 2 is equal to M21 into I1. You will use that concept, no? Mutually induced EMF, you will write E is equal to minus M into dA by dt. So self-induction for a long solenoid, how is it given? It is given as mu naught into N square into A into L. Or if you write small n as capital N by L, then it will be mu naught into capital N square A divided by L. This is another way of understanding. Similarly, mutual inductance of two closely wound solenoids is going to be how much? Mu naught N1 N2 into A divided by L, or mu naught into small n1 into small n2 into A into L. So if you write in terms of small n1 and small n2, L will be in the numerator. If you write it in terms of capital N1 and capital N2, L will be in the denominator. Am I clear with these points? Right. Derivations we have already seen. Now, the first question is, what is the self-inductance of a coil in which the magnetic flux of 40 milliweber is produced when 2 ampere current flows through it? So what is the flux? Flux is equal to 40 milliweber. So it is 40 into 10 power minus 3 Weber. How much is the current flow through it? I is equal to 2 ampere. So when 2 ampere of current flows through this coil, there is a flux of this much value produced. What is the self-inductance? L is equal to phi by I. We know that phi is equal to Li. So L is equal to phi by I. Phi is how much? 40 into 10 power minus 3 divided by 2. Cancel them. So answer will be 20 into 10 power minus 3 Henry, or it is going to be 20 millihenry. Understood? Shall I proceed? Try this. Simple one. A 200 turn coil of self-inductance 20 millihenry carries a current of 4 ampere. Find the magnetic flux linked with each turn of the coil. Hmm? 0.4 millihenry. Flux flux எப்படி ஹென்ரில இருக்கும்? 0.4 milliweber. Do and see. Zero point four. Milliweber. Is that what you're also getting? Okay. So what is the formula? Flux is equal to L into I. But here the flux you need to remember is it is N into phi is equal to L into I. What is the value of N? It is 200 into flux is equal to what is the value of L? 20 into 10 power minus 3 into what is the value of I? It is 4. So it should be 80 into 10 power minus 3. Right? But the question is very clear. Find the magnetic flux linked with each turn. So this is a magnetic flux linked with the total coil. But for each turn, what are you supposed to do? You need to have only 5. So you will have 200 here. So this will be 40 into 10 power minus 5, or it is 4 into 10 power minus 6 Weber, or it is going to be 4 micro Weber. Four into 10 power minus 7. Purila. Did I miss something? So N5 is equal to L into I. N is 200 into 5 is equal to 20 into 10 power minus 3 into 4. Edra? Enga? India? Okay, 4 into 10 power minus 4 போட்டுக்கலாம். But the answer came out to be 10 power minus 7. Actually, yeah. Here, I wrote it as 4 ampere. No, look at the solution. Unit was not given. There is a misprint in my sheet. So if it is 4 ampere, it is 4 into 10 power minus 4. Our answer is right. If it is milliampere, it is 4 into 10 power minus 7. Total கொடுத்தாங்கன்னா multiply both. 80 into 10 power minus 3 is the answer. Total magnetic flux is this much. Magnetic flux per unit turn is going to be L into I divided by capital M. கொடுக்கலாம். கொடுத்து கூட கேட்கலாம். N is only to confuse you. புரியுதா? Okay, there is a mistake, I think. Okay, leave this. Induces a anon வந்ததுனால EMF தான் இருக்கணும். EMF of 20 volt. The rate of change of current of, I think there is a numbers are not come down. Leave it. எல்லாமே அப்படிதான் print ஆயிருக்கு. There is a mistake. I'll get it checked. Copy paste பண்ணும்போது தப்பா இருக்கு. இது கரெக்டா இருக்கா? An inductor of 5 Henry only. Okay. An inductor of 5 Henry inductance carries a steady current of 2 ampere. Sorry about this. I'll have to copy the questions again. Leave it. I'll go to the next concept. Tomorrow I'll solve the problems. Shall I proceed? This is another important thing. No, sir, the doubt. Okay. So shall we proceed? Right. So the last topic of this chapter is, actually it's the last topic, but I missed one more topic in between, which is called as eddy current. That's a theoretical topic, but I'll finish this first. That can be treated like a problem. That's not a concept, actually. You can treat it like a problem. Okay. So next is, we'll discuss about AC generator. Okay. So as the name suggests, right, what is a generator? Something that can generate voltage, right? But what kind of a voltage is it going to generate? It is going to generate AC. So it is going to generate an alternating voltage, meaning there is going to be a voltage that will have a change in its direction with respect to time, right? If that should happen, right, first thing is this AC generator is supposed to be a device that works on the principle of Faraday's law of electromagnetic induction, right? What should happen? See, logically, you tell me, if you want a device to generate EMF, will you connect it across any other source of EMF? Obviously, no, right? You cannot give an electrical input and take an electrical output. That doesn't make sense, right? That is why when we think of a generator, what we need is, you can think of this device as something that converts mechanical energy into electrical energy. In the sense, we are going to use a mechanical energy to put the system into rotation and generate electrical energy out of it. But when you're going to put the system into rotation with the help of mechanical energy, the question is what is happening within it for the EMF to get generated. So as I told you from the beginning, right, there is only one concept in this chapter. What is it? If there is a change in magnetic flux with respect to time, EMF is induced. That's it. If there is a change in magnetic flux with respect to time, and EMF is induced, right? So basically, an AC generator is a device which converts, right? Listen to this carefully. AC generator is a device which converts mechanical energy into electrical energy. And how is it going to work? For which we have two permanent magnets which are fixed, and they have a concave shape here. So due to this concave shape, what will happen is there will be a magnetic field which will be produced from the North Pole to the South Pole, right? Now the thing is, you need to have a wire or a coil through which you are able to generate the EMF. So for which what we'll do is, we will take a coil and place it in the magnetic field, and once it starts rotating, what will happen? See, suppose assume my hand is the coil. Okay. This is the direction of magnetic field. So when the coil and the magnetic field are like this, what is the flux associated with this coil? See, this is the magnetic field. This is the coil. What is the flux associated with the coil? It is BA cos theta. B is there, area is there. Cos of, what is the angle between B and areal vector? It is 90. So when the coil and the magnetic field are parallel to each other, areal vector is like this, no. Areal vector is perpendicular to the coil. So magnetic field and areal vector are going to be perpendicular. Hence, in this case, the flux associated is 0. Okay, I'll just make a change. If it is like this, magnetic field and area, again still 90, right? So in this case, the flux associated is 0. Let's say I am able to use some mechanical energy to put this coil into rotation. When I put this coil into rotation like this, so between t is equal to 0 to some time t, what has happened is the coil has turned from 0 to 90 degrees. So when the coil has turned from 0 to 90 degrees, what is the change in the areal vector that is taking place? Initially, the areal vector is 90, and when it has turned like this, what is going to be the areal vector? It will be 0. So is there a change in flux taking place? So initially, what was the flux associated? 0. When it has come like this, what is the flux associated? It will be maximum, because B is in this direction. Aerial vector for this also is in the same direction. So B and A being in the same direction, flux will be maximum. So I'm going to make one complete rotation into 4 equal parts. That is, when the coil has rotated from 0 to 90, 90 to 180, 180 to 270, and 270 to 360. So in that complete rotation, what is happening is, there is a change in direction. There is a change in the angle between the aerial vector and the magnetic field, due to which there is a change in flux taking place. And due to that change in flux only, what is going to happen is EMF is induced. Okay. So let's see how the construction is made. Did you understand this logic? Am I clear? So if you want to design this kind of a device, what is the basic construction you're going to use? So all that you need is, first thing, magnetic field. So to generate magnetic field, what do you need? You need 2 permanent magnets. So you'll take 2 permanent magnets and keep it, in which you place an armature coil. You place a coil, the coil's name is armature coil. And this armature coil is the one which is connected to the load. Load in the sense, the devices which are going to take this energy. For example, if there is a power cut here, right? If I use a generator, what do you think will happen? All these devices are again going to start working, right? Depending on the load of the generator, you will be able to see that these devices will work. So these devices, that is a fan, tube light, everything is what is called as the load. These are called as electrical loads. So these are all electrical devices, no? So the armature coil is connected to two slip rings here, which are in turn connected to the brushes. So these brushes are going to be called as the carbon brushes, and these brushes are the ones which create a connection between the generator and the load. Are you able to understand this point? Right. Now, so let us assume that the coil is like this in the first case. Right. Okay, I'll show it in a different way. So there is a magnetic field existing in this direction. So initially, I'm saying that the coil is kept like this. Initially, the coil is kept in this way. So what is the flux associated with it? At T is equal to 0, what is the flux associated with the coil? Is it not 0 itself? So at T is equal to 0, the flux is also going to be equal to 0, right? So when it makes a rotation from T is equal to 0 to some time, any idea how much the time is going to be? I told you I'm going to break the whole rotation into 4 equal parts. So if the time taken for one complete rotation is 1 time period, then how much time will it take to rotate from 0 to 90 degrees? It will take 1/4 of the time period. So from T is equal to 0 to 1/4 of the time period, what is happening is, the flux is going to change from 0 to flux is equal to BA cos 0, or it is going to change to maximum. So is there a change in flux that has taken place here? Yes. Right. Similarly, at T is equal to T by 2, what will happen? The coil would have made a 180-degree turn. So again, if you observe, the flux is going to be 0. So what has happened? Flux has gone from 0 to maximum value. Again, from maximum, it has come to 0. And T is equal to 1 time period. Where will it come back? So initially, it is like this, no? With respect to this 180-degree means, it is going to be, flux will be equal to BA, and this time it is going to be cos 180-degree, or it will be, so what has happened? The flux has gone from 0 to maximum, maximum to minimum. And again, it will go back to 0 and it will start. So this clearly indicates one fact, that there is a change in flux taking place due to the rotation of the coil, right? So Faraday's law states that whenever there is a change in magnetic flux, there is EMF induced. So till now we didn't find what is the EMF induced. We only understood that there is a change in flux. Now my question is, listen to this carefully. Now I'm going to explain the derivation for it. Listen. So derivation is, if I take flux, I know that flux is equal to BA cos theta, right? So I've been telling one point from the beginning. Flux depends on three parameters. What are they? B, A, and theta. Theta is basically orientation. So listen to this. For you to change the flux, you can change any one of the three parameters and keep the other two constant, right? So when we discussed about motional EMF, tell me which parameter was changing with respect to time. Distance means the area was changed. Time up. Okay, that is the area. Okay, so area was changing in the case of motional EMF. There were certain cases where B was changing. We saw some problems, no? The first example that we saw, there was a magnetic flux of this much by 0.7 existing. From 0.7, it fell down to 0. Then what is going to be the EMF induced? There, the magnetic field was changing. Whatever, yeah, the coil is going to be stationary, but the magnetic field will change. But in this case, if you observe, right, this is one such example where you can see that there is the angle that is changing. So why is the value changing from 0 to maximum, maximum to minimum? Because of the rotation of the coil. So basically the magnetic field's direction is fixed. But what is happening is, see, this is the direction of magnetic field, but when the coil is rotating, the angle made by the aerial vector with the coil is changing with respect to time. Visualize it. Are you able to understand? The angle between the magnetic field and the aerial vector is changing with respect to time. It is coming from 90 to 0, 0 to 180, 180 to 270, 270 to 360. Again, the same cycle, right? So what I'm trying to tell you here is, if this coil is going to rotate with an angular speed of omega, right, with a constant angular speed of omega, then the value of theta here is written as theta is equal to omega into t plus half alpha t square. But since the value of omega is constant, alpha is 0. So we can say theta is equal to omega into t. Does this make sense? So what can I write the flux value as? Flux is equal to B is constant, A is constant, because you're using the same rectangular coil, same magnetic field, but the angle is changing. So I can write it as BA cos of omega t. Makes sense. So it is going to be BA cos omega t. But I know the fact that EMF is equal to minus d phi divided by dt. So if I differentiate this, I'll get minus BA into derivative of cos omega t is going to be minus sine omega t into derivative of omega t, chain rule. You need to have omega. So minus of minus will be plus. So it is going to be BA omega sine omega t. So the value of EMF induced is going to be BA omega sine omega t if the coil has only one turn. But in reality, coil will not have one turn. You look at this itself. This itself does not have one turn. You can do nothing with one turn. Okay. So it will definitely have n number of turns. So when n number of turns are there, you just need to multiply with n here. And this gives us a point stating that the EMF is equal to NBA omega into sine omega t is there. No. This NBA omega is what can be replaced with E naught. Okay. You call it as E naught into sine omega t, which is going to be the EMF. So this clearly tells me that due to a generator, which is going to rotate in the format that we discussed, the EMF getting generated is a function of time. So till now, we didn't get any EMF that is a function of time. All we got is 2 volt, 3 volt. We got a fixed value. but this is the case where we are getting the EMF as a function of time, and that is why we call it as AC. Okay. And the most important thing is this is going to be the leading factor for our 7th chapter. So this is the expression we'll be using everywhere. It states that E is equal to E naught sine omega t. Is the derivation part clear? Okay. So I just need to give you the graph for it. I'll explain the graph, then you can copy it. So what is the value of EMF? EMF is equal to E naught sine omega t, right? So when you plot the graph between the value of EMF and time, remember this EMF is what is called as the instantaneous value. Why it's called as instantaneous is because by you plugging in different value of time into it, you will get different values of EMF. Okay. So you know the graph for sine. So the graph for sine is going to look something like this. It keeps on going like this, right? So this is the basic graph for sine, but what is the range of sine? -1 to +1, right? But if the question had been only sine theta, then the range would have been -1 to 1. But here the value is not sine theta, it is E naught times sine theta. So the range will be between -E naught to +E naught. So here if I take, then this is going to be E naught, and this will be, and this E naught is what is called as the peak value. It is called as a peak value because it defines the amplitude of this particular alternating EMF. Am I clear with this? Now see what will happen is, this expression will help us to derive the EMF at any point. So this is, I told you, no, in the beginning I told you 0, t is equal to 0, t by 4, t by 2, then t, right? The meaning of it is, this is 0, right? This is t by 4. This is t by 2. This is 3t by 4. Sorry. Yeah. 3t by 4, and it is going to be t. Are you able to understand this point? Right. Now see, you know that the value of omega is, do you all know this? Omega is defined as 2 pi by t or 2 pi f, right? So the same expression can be written as E naught sine of 2 pi by capital T into t. Now you plug in different values and see. When you put t is equal to 0 here, small t, capital T is fixed. When you put small t as 0, EMF will come out as E naught sine 0. Sine 0 is 0. That's why the EMF is 0. When you put t by 4, so E is equal to E naught into sine of 2 pi by capital T, that is omega, into, in the place of small t, what should I put? T by 4. When I put this, t and t will get cancelled. 2 will cancel this 4 twice. So you get E naught sine pi by 2, which is E naught itself. That is where you got the maximum value. So like this, you want any value. Let's say they're asking you what is the value of EMF at some instant. At some instant, 5t by 6. What is that all you need to do? You write E is equal to E naught sine 2 pi by t. In the place of t, substitute 5 pi by 6. Yeah, sorry, 5t by 6. You will get the answer. That is basic mathematics of it. I hope I'm clear with this, right? So I can make a note of this. Hmm. Oh, working, see, எது படிச்சாலும் first you need to answer construction, then working, then of course, then the mathematical equation. Equation நம்ம படிக்கலையா? அதனால தான் நான் அவ்வளவு எலாபரேட் பண்ணி நான் எக்ஸ்பிளைன் பண்ணேன். 12th derivation important. அதான் S is equal to UT plus half. அதுதான் ஆக்சுவல் ஃபார்முலா. அதுதான் ஆக்சுவல் ரிலேஷன். S is equal to UT plus half it square இருக்காங்க. அது பதிலா theta is equal to omega naught T plus half. அது யூஸ் பண்ணி ஆல்ஃபா 0ன்னு எடுத்தேன் because the coil is rotating with constant angular speed. அதனால ஆல்ஃபா 0. இது அது கிடையாது. அது வந்து இனிஷியல் பேஸ்ன்னு சொல்லுவாங்க. சரி என்ன பண்ற? Finish the diagram. Yes. Done. Done. So I've written these points, the T/4 and all those things. Right. So just make a note of that point along which I told you. So whatever is the value of small t that is given, substitute it to find the instantaneous value. To find the instantaneous value, substitute the value of small t. That's it. Okay. Okay. So that's it. And we have one more concept, eddy currents, and yeah, you can actually treat that also as a concept, the energy stored and anything. Like you remember the energy stored in the what? Sorry? Half CV square no argument. So half CV square, right? So similarly, the energy stored in inductor is given as half Li square. Instead of capacitance, you have inductance. Instead of voltage, you have current. Okay, that is just a 3 or 4 step derivation that we'll see tomorrow. And one last concept that we need to discuss is eddy currents. We'll discuss about that. Irrespective of whether it is there for the syllabus or deleted, we'll discuss it because you need to know that there are two things that you need to know for next chapter when it's called transformers. One is called eddy currents and the second is hysteresis. In the 5th chapter, I didn't teach you what is hysteresis also. But these two losses will come in a concept called as transformer. Another tomorrow I'll teach you those things. Eddy currents, and we will do the derivation of energy stored in inductor, and we'll do the problems. I showed you, self-inductance and mutual inductance. With that, this chapter is over. So Monday we'll get started with 7th chapter. Okay. So any other questions? All clear?
No, sir.
Okay.
No,
We'll
sir.
wind up.
Thank you, sir.
Thank you, sir.
Yeah.